Hello everyone, my name is Ioanna Zavogianni and I'm a doctoral researcher at the Brain Imaging Center of the Research Center for Natural Sciences in Budapest, Hungary, and also the Multilingualism Doctoral School at the University of Pannonia in Hungary. Today I'm going to present to you a preliminary version of our results of the randomized controlled trial that we conducted in order to investigate the music training that we designed for children with dyslexia. So, why do we choose music? Music has transfer effects to linguistic abilities, such as speech prosody or verbal memory. There have also been some numerous music training in the past that have shown literacy effects and also improvement in the underlying aspects of reading disorders, such as phonological awareness, categorical perception, phonological, auditory or working memory, etc. The aims that we set for our current study were the following. First and foremost, we wish to develop a new music training that emphasized on both entrainment and the underlying aspects of reading disorders. Also, we wanted to assess the efficacy of this new music training in the improvement of reading disorders. For these purposes, we designed a randomized controlled trial study within the evidence-based practices. We also wanted to mention that this is the first RCT that has an active control group as a comparator group to the music training group, as we will see later. Let's talk a little bit about the design of the RCT study itself. For the screening part, we did the neuropsychological measurements, reading test, and happiness test, and then after that, we began with the pre-training phase, which is the first actual phase of the RCT study, and we ran the behavioral and DHG measurements, as we will see later. After that, I randomly allocated the participants into either the music training group or the spelling training group. And in the end, we finished with the post-training phase, where we conducted the same measurements as we did in the pre-training phase. Our participants were children from 8 to 11 years old. They were Hungarian native speakers and they had reading disorder. However, they had no comorbidities or hearing disorders. As you can see on the donut chart, our participants in the recruitment and screening phase were 48, but after that, in the actual RCT phase, we were left with 41 participants. Now let's talk about the outcome measurements of the study. As I explained in the beginning of the presentation, today I'm going to focus only on the age results of the study and only on a short version of the analysis. And that's why I'm going to explain now which paradigm we used for the measurements. The paradigm that we used is called a speech multi-feature paradigm, and it's an ideal paradigm in order to record the mismatch negativity ERP responses under a very short period of time. The paradigm itself consists of one standard stimulus plus X deviant stimuli, as we will see in a bit. Also, the mismatch negativity component is an event-related potential component that peaks during the 180 to 280 millisecond window. So now let's talk about the experimental procedure. On the top of the screen, you can see the stimulus sequence that was auditorily presented to the participants. We asked the participants to listen to the stimuli while watching a movie without any sounds or subtitles, and we particularly asked them to focus on the movie that they were watching instead of instead of the stimuli that they were listening to. So now let's focus on the stimulus design. As you can see, the stimuli were formatted in a CVCV format, and we followed, for this reason, we followed the Hungarian phonological rules. And as I said earlier, the speech multi-feature paradigm consists of the standard stimulus, which for us was keke. And for this reason, we created 5 different types of deviant stimuli. You can see that we made vowel changes, 2 consonant changes, and 1 stress change. All these changes were made on the first syllable of the stimulus. The experiment lasted for 17 minutes, and during the EEG recording, we recorded 64 channels with a brain amplifier by the brain products, and also on a 1000 hertz sampling rate. Now let's have a closer look at the results. In the analysis, we emphasized on the mismatch negativity peaks, and we calculated the difference curves in the vowel, stress, and consonant conditions. For this reason, we focused on the FCZ channel because the mismatch negativity peaks appear the best there in this channel, and we also calculated the difference curves on the base of the comparison between the pre-phases versus the post-phase in both the music training and the spelling training group. In the statistical analysis, we conducted the repeated measures ANOVA with a specific factor of interactions between phase and group. And the time window that we selected for this was 190 to 290 milliseconds. Let's see the results of the first condition, the first vowel. So you will see that the results about the music training group appear on the left side of the screen. The results for the spelling group appear on the right side of the screen. Also, the black peaks represent the pre-training phase peaks, and the red peaks represent the post-phase peaks. So as you can see, we can clearly see a very large mismatch negativity for the music training group, for the post-training phase, and also that there is a large difference between the the pre-phase and the post-phase. A similar pattern is represented by the spelling training group. However, on the in the statistical aspect, you can see that there is clearly a difference, a significant difference between the music and the spelling training performance, because you can see that the participants that were exposed to the music training had a much larger improvement in the post-training phase. Also, we had a tendency effect in the phase by group interaction, and also we had statistically significant post-hoc comparisons concerning the music training group. For the second condition, the second vowel, you can see that there is clearly, again, mismatch negativity for the music training group, and there is also a very clear representation of what we expected to see on the EEG peaks, namely that we wanted to see the pre-training phase peaks on the positive side of the axis, and the post-training phase peaks should be on the clearly negative side of the axis. And this is also represented clearly and in line in the statistical analysis as well. We cannot say the same thing for the spelling training group, even though you can see that there is a large mismatch negativity, because there is also a mismatch negativity for the even for the pre-training phase. If we look into the statistical results about the music training group, we can see that we have statistically significant results for all the categories, for the phase and also for the phase by group interaction, and also statistically significant post-hoc comparisons for the music training group. As for the stress condition, we can see a very characteristic uh, sign of mismatch negativity peaks for the music training group, and here as well we can see this difference between the negativity and the positivity of the post phase versus the pre phase respectively. um, However, we cannot see this for the spelling training group because we can see that there was an even larger mismatch negativity in the pre-training phase. As for the statistics, we have a tendency effect in the phase for the music training category, and also statistically significant results on the phase by group interaction, and also a tendency effect for the post-hoc comparisons for the pre versus post-training phase for the music training group. If we talk about the condition of the first consonant, we can say that in both training groups, we have no statistically significant results. Um, However, we can say that in the music training group, there is a small significant mismatch negativity, and also a much of a difference from the pre-phase towards the post-training phase. And this can also being represented in the figure of the statistics. Finally, for the second consonant, we can see that in both the music and the spelling training group, we don't have a clear mismatch negativity, um, and also we don't have any statistically significant results or post-hoc comparisons. So, if we were to summarize these findings, we would say that we found statistically significant results for the two vowel condition and also the stress condition, and specifically a tendency effect for the first vowel condition. However, we found non-statistically significant results for the two consonant conditions. So, what do these results tell us about the music training as an intervention method itself? So, children that were exposed to the music training during the RCT study detected changes in vowels and prosody during the post-training phase. This shows that there is a training efficacy for improvement in vowels and changes in prosody. However, we cannot say that the music training was efficient enough for the consonant detection. If we were to conclude a few things from here, would be that our music training can be effective to train the detection of phonemic and also prosodic contrasts, and also more importantly that our findings are in line with previous findings in previous music training studies. So as a result, we can say that our music training, this present music training, can be applied either as a main or as a supplementary intervention to facilitate aspects of reading. If you want to know more about the RCT study and the training itself, you can check out our website where you can see more information about the study and also about the activities that we applied during the intervention. Last but not least, I would like to thank the project that I'm involved in, the Neo-Presidency project, which is a European Union funded project, and also my two supervisors, Dr. Ferenc Honbolygó and Dr. Maja Kelić, and also the rest of the team. I would also like to thank our children, the children that participated in the study. So thank you very much for watching my presentation, and if you want to discuss more about music training methods and clinical applications, you can contact me via email or Twitter. Thank you very much.